Hi all, welcome to Aryan tutorials on engineering drawing. So now we discuss Vernier scale, a simple example. So the problem is given as draw a Vernier scale of representative factor 1 by 25 to read centimeters up to 4 meters, and we have to show the lengths 2.39 meters and 0.91 meters. So by constructing a Vernier scale, we need to represent these two dimensional values on Vernier scale. So first we find out the maximum length of the scale. That value should be inconvenient to draw on a engine on a drawing sheet. So here the length of the scale can be determined by using the representative factor. So the value is representative factor into maximum length of the scale, that is equal to 1 by 25 into 4 into 100. 4 into 100 means here the maximum length of the scale in the problem is given as 4 meters. So we need to convert this into centimeters. For that I have multiplied with 100. So this value could be in centimeters. So the value is obtained as 16 centimeters. So 16 centimeters is the line which represents 4 meters line on a drawing sheet. So now step by step we draw a Vernier scale. Assume it is as a drawing sheet. Now draw a line with a length equal to 16 centimeters. Then construct a rectangle with a convenient height for constructing the Vernier scale. Now divide it into how many? 4 equal parts. So divide it into 4 equal parts and give the numbering as here the 0 is missing. So here the 0, 1, 2, 3. Give the numbering as 0, 1, 2, 3. Now divide the first division into again 10 equal parts, which represents 0 0.1, 0 0.2, 0 0.3, 0 0.4 up to 0 0.9 and 1 meters. Okay, and give the numbering as 0, 0 0.1, 0 0.2, 0 0.3 up to 1 meter. Now for constructing the Vernier scale, take an additional dimensional division, one division, take the extra division to the left side of the Vernier scale. Here first I am representing the units. Main units are in meters and sub units are also in meters like 0 0.1, 0 0.2, 0 0.3. Next, divide, we can also divide the remaining divisions also into 10 number of equal parts for representing the decimal values of the meters, that is 0 0.1, 0 0.2, 0 0.3 meters. Next, take an additional division to the left side of the Vernier scale rectangle and divide the total, the distance, that is 0 to an additional division up to 0 to additional division, and take another rectangle above that and divide it into 10 equal parts. So here each division represents 0.11 meters. How it could be means, here we have taken extra point as 1.1. By considering the length of 1.1, we have constructed a rectangle, small rectangle, that is Vernier scale, and we have divided it into 10 equal parts. That means 1.1 by 10 means 0.11. So here each division represents 0.11 meters. So give the numbering as 0.11, and this second division will be 0.22, 0.33, 0.44, 0.55, 0.66, 0.77, 0.88, 0.99, and last one will be the 1.1. Okay, so this is the Vernier scale we have constructed. By using this, we need to show 2.39 meters and 0.91 meters. So for that, first we consider 2.39. So here for representing this 2.39 on this Vernier scale, first we need to subtract the 9 related value on Vernier scale. So here the 9 related division is 0.99. So first take this 0.99 and subtract from this value. So when we subtract 0.99 from 2.3, we get as point sorry 0.40, 1.4 we get. Okay, 2.39 minus 0.99 means we get 1.40. So here we have subtracted 0.99. So draw a line from 0.99. Draw a vertical line from 0.99 and the remaining value is 1.4. So 1.4 means here the value is 1.4, 1.1, 1.2, 1.3 and 1.4. And from the 1.4 draw a vertical line. Okay, so this much distance will be equal to 2.39. So then draw a vertical line, sorry, dimensional line and represent 2.39. So once again listen here, for representing this point 2.39 we have to first consider the division related to 0.09. So here the related to 0.09 is 0.99. So take this 0.99 and subtract from the dimensional value that we are going to represent. So 2.39 minus 0.99 means we get 1.4. So we have subtracted 0.99 and we have drawn a line and the remaining distance is 1.4. So here from 1.4 we have drawn a vertical line, then the distance between these two vertical lines will be the desired dimensional value, that is 2.39 meters. Okay, and similarly we need to represent 0.91. So for this also, first consider the division that is related to zero point 0.01. So here 0.01 related division is 0.11. Take this 0.11 and subtract this distance from 0.91. Okay, so here we have subtracted, we can subtract the value 0.91, sorry, subtract the value 0.11 from 0.91. When we subtract that we get 0.80. Okay, so first draw a line from 0.11, then draw another line from 0.80. So where is the 0.80? So now we have to represent 0.80. So the remaining distance is 0.80. Means here the first division is 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7 and zero point 0.8. So this one is the 0.8. So when we draw a vertical line and represent the dimensional value, it can become 0.91. 0.80 plus 0.11, that is equal to 0.91. So draw a vertical line from 0.8. Okay, then draw the dimensional line in between these two vertical lines, then represent the dimensional value, that is as 0.91. So this is the Vernier scale, the simple Vernier scale. We can represent the two decimal points of the main unit, that is meters. So this is also similar to the diagonal scales. Generally the diagonal scales are used to represent the two decimal points of the main unit. In the same way the Vernier scale is also used to represent the two decimal points of the main unit. So I hope you understand my explanation about the Vernier scale. If you have any doubt, please feel free to give a comment. And here I am requesting you to please subscribe to my channel and please give me the suggestions to improve my explanation for explaining more efficiently. And try to click on the ads which are streaming while starting my video so that it can be helpful for me. And thank you so much for watching my video. Thank you all.